Dear students, in this lecture we shall be discussing about secondary storage memory concepts. So, what are the secondary storage devices? As in the previous lecture, we discussed about the primary memory concepts and what are the different types of primary memories. Now we shall be discussing about the secondary storage devices. Secondary storage devices are used in computer system to supplement the limited storage capacity of primary memory, that is RAM or the ROM. As the primary memory is volatile in nature, so the data is lost when the power goes off. But to overcome this limitation, we are having another type of memory, that is secondary storage devices, because we need a certain type of memory which can store our data. As we come across in today's world, we are having very large servers. We are every now and then we are clicking over photos, we are clicking so many things by our mobiles, and we are making certain videos, then we are uploading those on social media. Then there is a lot more data uh, per second which is being generated by the science and technology. So to save that data, we need a large amount of memory. So we are having very large data centers being monitored by big organizations like Google, like Facebook, like Twitter. So to store the data, this kind of data, which is very necessary these days, and we can use that data in the future, we need to have certain kind of memory which can permanently store our data, because this was the limitation with primary memory, because that primary memory is volatile. Though it is very fast memory, everything which happens, uh, what actually calculation happens by the computer, it happens in the primary memory. It is very important memory because computer computes everything in the primary memory. But after computation, we have to store the results, we have to store the data in some kind of memory, and that memory is called secondary storage memory. Now these storage devices are used to store data and instructions permanently, because we need to have permanently store that data as well as the instructions. The data stored on these devices is non-volatile in nature, because once that data is saved on these secondary storage devices, it is permanently stored there. It is non-volatile, unlike primary memory, because in primary memory, as the power goes off, the contents vanishes. But it is not the case with secondary storage devices. So broadly, these secondary storage devices or secondary storage memory can be categorized in two major categories. These two major types of secondary storage memory or devices is direct access storage devices and sequential access storage devices. So what are the direct access devices? Direct access devices can be accessed using a directory that contains a name given to the data file and its address or storage location. Using this address, the device head can directly reach to the location and retrieve the data. Because you see, we are having data stored in our hard disk. Whenever we want to play some music, we want to go a certain file of uh, our interest, we go to the directory, some drive like C drive, D drive, E drive of the computer. Then we open that drive and search for our folder or file, and we click that and we go to our required data. So because we have direct access, we are going directly to the data which we have stored on some secondary location on the hard disk, or it could be pen drive or any secondary storage device. Magnetic disks and optical disks are examples of direct access storage device, because you see, When we say magnetic disk or optical disk, optical disk mean CDs, but we say compact disc, DVDs. We can directly switch to the song or the track we want to play. We directly can go to that particular location. So that's why when we are having the capability of going direct to a particular location, that kind of access to your memory location is called direct access devices or direct access memory devices. So optical disc comprises of all these CDs, CD-ROM, DVD-ROM, etc. All these devices are known as optical discs, and these optical discs are the example of direct accesses. An optical storage is a medium from which data is read and written by lasers. So when these compact discs are made, they are made with the help of laser beam. An optical disc is a flat, usually circular disc that encodes binary data in the form of bits. Because computer understands binary language, so everything which is stored on these compact discs, it is in the form of bits. But in the form of what? In the form of bits. What is bit here? Binary value of 0 or off due to lack of reflection when read, and lands. Two things, bits and lands. Bits is 0 or off, and lands is binary value of 1 or on due to reflection when read. So that's how we make our compact disc. So these optical discs are the compact CD discs, use the concept of laser beam by which we can store some data on the disc. You see here I have put binary value of 0 or off and binary value of 1 or on. So what does this signify basically? Actually, why 0 and 1? 0 and 1 are there because we want to compute certain things and we need to have some mathematical things here. But in actual sense, it is off or on. And when we say off, on, or false, true, true or on or one and the same thing. False, off, or 0, one and the same thing. So, because when we say there is nothing like here it says pits, so I mean that is due to lack of reflection when read. So that is 0. And when there is a land, there is something which we can feel it is true or on or 1. In actual sense, we don't see 0 and 1 flowing in the circuitries. It is always the charge. It is the whether the current is there, whether the charge is there. So we say it is on, and if it is not there, then we say it is off. Due to reflection on a special material, often aluminium, that concept of pits and lands, the special material used called aluminium on one of its flat surfaces. So some chemically used that aluminium is used there. Optical discs can store data on the different types of the disk like compact disc, CD-ROM, DVD-ROM, etc. All these optical devices. Optical discs are most commonly used for digital data archival, storing music, video, or data and programs for personal computers. So I think most of us have seen these optical discs or CDs or DVDs. So what they are used for? They are used for storing some um, data like storing music, storing your videos, storing your photographs, your programs, personal computers, etc. So these are the direct access devices. All the optical discs, they come under the category of direct access devices. Now you are having another type, that is floppy disk. In the earlier days, we used to have this disk is called floppy disk. These are also called as flexible disks. These are used in small microcomputer systems as well as mini computers. The floppy disk is permanently sealed in a plastic coated jacket. The jacket of the disk has a small slot to permit the read-write head to contact the disk. The data is written on track, which are concentric rings of the data. So this was in the earlier days when we were not having CDs. We used to have this floppy for booting the system also to start your computer system in the 90s. Time we were having, we used to have these earlier 90s. Used to have this floppy disk. We used to put this floppy disk into the computer, and then it boots, and then we uh, take this out of the computer, and computer runs. So uh, this was in use in the early 90s. Then we are having hard disk. A hard disk drive, commonly referred to as hard drive. Hard disk or fixed disk drive. It is non-volatile secondary storage device which stores digitally encoded data on rapidly rotating platters with magnetic surface. That is magnetically surfaced. So you see this diagram. We are having, uh, you know, these concentric disks are there. They are coated magnetically from both the sides, and then uh, this size of magnetic disk is made with these disks. Huge size is made with many number of disks. So this is hard disk, which is having very large capacity to store the data permanently. We'll discuss the different components of hard disk in the next lecture. But this is a very major secondary storage device which is used to store the data on the large scale. So these are there are tracks on this disk, like the tracks are there on CD. Then you are having this recording head there. This recording head, this is your recording head. It directly goes to the particular track, and then from there it fetches the data. So we can this head can directly move to the place which we are looking for. So that's why it's a direct access device. Now there are certain properties. The hard disk drive has a set of magnetic heads or read-write heads for both surfaces of each disk on the spindle. That's I already told you. So these are the spindles. The spindle, and this stores the data on both the sides. The magnetic hard disk is an electromechanical device which consists of some smooth metal plates and disc coated on either side or surface with a thin film of magnetic material that I already discussed. The disc drive consists of a motor to rotate the disc back about the spindle. Yes, this disc drive consists of a motor that rotates the disc pack about the spindle, because this is your spindle. This is the spindle, and these magnetic discs, they are rotated about this around this spindle, and for that it is required to have a motor which will help rotating these discs around the spindle, because it has to come under the head. Then head will read the data, and when head is reading the data, it means that data that we are looking for will be fetched. The information is stored on the magnetic surfaces as bits 0 and 1 on the concentric circles as tracks. Obviously, because information stored will always be in the bits, in the form of bits, that is in the form of 0 and 1, which I already have discussed what does 0 and 1 means and how they are created on the disks. Each track is divided into sectors of same density. Now you see, this is your track. These are the tracks. Tracks mean these concentric uh, rings will be there. They are known as tracks. And further, these tracks are divided into, these tracks will be divided into sectors of same density, mean it will store the same size of data. The set of corresponding tracks of all surfaces of all the disks constitute a cylinder. Now you see this. This is the sector and it's concentrating right from the lower one to the top one. The disks at the bottom and disks at the top, and these continuously will form different concentric rings will form different cylinders of this disk. So these are the properties of hard disk. They are also used for this. Hard disk is the example of direct access. Now you come across another type of access. The another type of access is called sequential access storage devices. The data stored on these devices is accessed sequentially by the computer. It is like music cassettes. To listen fourth song, we have to forward first three songs. In earlier days, we don't find these tapes these days very oftenly, but in earlier days, we used to have music cassettes, and they were a magnetized material. For that, what we have to do? We used to have, if we want to go to our next track or the previous track, then we have to forward that or backward that. For example, if we want to listen the fourth song in the cassette, then we have to either listen the first three songs or we have to forward to the fourth song. We cannot directly go to fourth song. It may forward us very fast, but we have to first of all have to track all these the data which come in the place before we reach into the fourth song. That's why it is called sequential access, because sequentially, if we have to go to the last word of the file, then we have to read all the words or the sentences from the beginning to the last. So sequentially we are moving to the last one. Now magnetic tapes, there are different kinds of tapes, and magnetic tapes are the best example of this sequential access. Tapes are used for recording and storing data for computer processing. It is plastic reel similar to long lengths of movie film. The process of reading and writing of data is carried out on a device called tape drive, and the records on magnetic tapes are stored in sequential order. So this is the typical example of magnetic this sequential access. This magnetic tape is an example of sequential access. So that's about secondary storage device. It's not about the primary memory is very important or secondary memory is more important. It's about the nature. What is the fundamental difference between primary storage device and the secondary storage devices? Primary storage devices are those devices, are primary memories, that memory where computer actually performs the functionality or all the computation takes place in the primary memory. After computing the things, computing the data, that data is permanently stored on the secondary storage devices. Because after computation, we are supposed to have the record for future use, or we want to store our data. And for that, we are supposed to have some kind of memory which will store the data permanently until and unless we uh, deliberately delete that data or intentionally delete the data, it will remain there on those secondary storage devices. So this is the fundamental difference. Then different kinds of primary memory and the secondary material, it is there, that we already have discussed, but the fundamental difference is the which I already told you, and the cost also varies. Primary memory is a costly memory, but the secondary storage devices or secondary memory is cheaper than the primary memory. So that's all about primary and the secondary storage devices.